So the company that funded this research, in large part, Supra Research and Development, had a vested interest in understanding smoke taint, especially as it pertains to wineries and vineyards in the Okanagan Valley, because they want to help those industries tackle this problem. And so they came to my supervisor at the University of British Columbia, Okanagan, and said, we have this project, and we have a guy, me, who can do this work. And so here we are 3 years later, and we've done a lot of good work in that time. So from a sensory standpoint, for what you and I can taste, smoke taint is classically a really strong campfire aroma. And then on the palate, when you taste that wine, that smokiness, that strong sort of objectionable smokiness continues. And then at the back of the throat, you get what we call a retronasal taste that's associated with ash or ashtray. And these are sensory qualities in a wine that winemakers don't want. And we know from research out of Australia, as well as our own research, that this smoke taint problem occurs, or can occur, not always, can occur when grapes are exposed on vine to the smoke from forest fires, which here in the Okanagan Valley is obviously something that's front and center, especially the last 3 out of 4 years. I think we've had significant smoke problems in the valley. So. Jury's out on that. There's some anecdotal evidence. Some studies find, Merlots worse than Viognier, but they haven't been replicated. If you talk to growers in the valley, a lot of them will say that Cab Franc has a particular problem. We've done some work on Cab Franc, but nothing that would definitively identify that as a problematic compound. Mm-hmm. I would say it's more the knowledge that we have might suggest that thicker skin varietals could be worse, because these chemicals that are the presumptive causative agents of these off-putting sensory attributes are dominantly stored in the skins of the grape. So when plant material burns, you get a release of all kinds of volatile chemicals. And one class of these chemicals are called volatile phenols. And these are the compounds that we actually like a lot of times. They make your smoked salmon taste delicious. They make your scotch extra smoky, these types of things. But when you get them at very high concentrations and you get a broad variety of these, that's when you have this smoke taint problem. Now, these chemicals travel with the smoke plume, and if they interact with the grape on vine at a suitable time in the development of the grape, in particular after color change, that 2-week window after full color change, they're quite sensitive to this. These volatile phenols in the smoke will actually be absorbed onto the surface of the grape, onto that waxy cuticle that covers the fruit. And then once they absorb onto there, they will then migrate into the flesh of the fruit itself. And once inside there, they'll actually be chemically modified by the grape into different forms. And all of these forms that are in the grape, through fermentation, can lead to, in some instances, this smoke taint problem. For our field trials, we would go out in the vineyard and we would build a tent around some grapes and we would smoke them. The smoke that we used was generated from a ponderosa pine fuel source. That's what burns in the Okanagan Valley. If you look in the hills, it's dominantly ponderosa pine forests. And that fuel source is quite important because the volatile phenols that are produced in that smoke are in part a function of the fuel source. So the smoke taint marker compounds, if you will, that grapes are exposed to in Kelowna will likely be different than in Washington or California or Australia. So this means that while the sensory attributes of a smoke tainted wine are the same, that smokiness and ashiness. The chemistry in the grape differs. And as chemists, if we want to understand and help winemakers solve this problem, we have to understand that chemistry. So knowing what's regionally happening within a wine growing, or sorry, a grape growing or wine producing region is really important. And then following from that, we actually discovered that before our research, it was believed that these volatile phenols are present in the grape in two different forms. They're present in what's called a free form, which we can taste and smell. And then they're also sequestered by binding them up in sugars so that we can't taste or smell them. But what we found is that there's actually a third form. And this other storage form, we don't fully understand what it is yet, but it's pretty clear to us from our data that it may actually have a significant influence on the final sensory perception of smoke taint in the wine. So we're working to understand that relationship a little bit better. It's not going away. All the climate change forecasts tell us that forest fires are going to increase in frequency and severity, not just in the Okanagan, but in grape growing regions around the world. I think there's going to be a larger research push from academics as well as from the industry to find ways that you can protect the grape from the smoke, or on the other side of the equation, ways that you might be able to change your fermentation practices to mitigate the impact from a sensory standpoint that smoke exposure may have. And there's a lot of research that's currently going on this, not just in our lab here at UBC Okanagan, but also in Washington State. There's a great research program there, and of course in Australia and California there's some good research happening as well. So this past fall, we went ahead and did some field trials looking at ways that we could insulate the grapes from the impact of the smoke. And we're still sifting through a lot of that data, but we have some strong preliminary evidence that there may be avenues that grape growers have to protect their crop.